What is the cosmological constant's role in vacuum energy? Imagine the universe as a vast, mysterious space filled with unseen forces. One of the strangest ideas in physics is that empty space itself might hold a kind of energy. This idea is connected to something called the cosmological constant. The cosmological constant is a term in Einstein's equations of general relativity, which describe how gravity shapes the universe. Einstein originally added it to keep the universe static, but after discovering the universe was expanding, he thought it was unnecessary. Then, in the late 1990s, astronomers found that the universe's expansion is actually speeding up. This made scientists reconsider the cosmological constant as a possible explanation for this acceleration. Now here's where it gets really strange. In physics, vacuum doesn't mean nothing at all. Even in a perfect vacuum with no particles or light, quantum fields are still buzzing. These quantum fields have a baseline energy called vacuum energy. The cosmological constant is believed to measure this vacuum energy density, or how much energy is packed into empty space. The weird part is that quantum theory predicts the vacuum should have a huge amount of energy from all the tiny quantum fluctuations constantly happening. If this were true, the universe would be torn apart by this energy long ago. But observations show the vacuum energy is incredibly tiny, so small that it almost seems zero. This huge difference between what theory predicts and what we see is called the cosmological constant problem. It's one of the biggest puzzles in physics today. This mismatch makes scientists wonder if they're missing something fundamental. The idea that empty space has energy that doesn't fade away as the universe expands is already strange. But the fact that the predicted and observed values are off by a factor of hundreds of orders of magnitude is downright bizarre. It's like expecting a big wave and getting a tiny ripple instead. If we could find a way to tap into vacuum energy, it would be like having access to an endless power source from the very fabric of space. That's why some scientists and inventors dream about harnessing vacuum energy for power. Right now, the closest we've come is the Casimir effect, where two metal plates placed very close together in a vacuum feel a tiny force due to quantum fluctuations. It's real and measurable, but it's a tiny effect. It's nowhere near enough to power anything large. The role of the cosmological constant is to tell us how much energy the universe's empty space contains. It links the shape and expansion of the universe to this mysterious energy. Its current value is essential for understanding why the universe is expanding faster and faster. But why it's so small and how it fits into the bigger picture remains a mystery. Some theories suggest there might be a hidden mechanism that cancels out most of this energy, or maybe the vacuum isn't what we think it is. Until scientists figure this out, the cosmological constant and vacuum energy will stay at the heart of some of the strangest questions in physics.